Hi, good afternoon. Thank you very much for making all the way. I'm between you and your flights and most probably some other important things. My name is Govind Kanchi. I'm going to talk about Cosmos DB operations. How many people here use Cosmos DB today? Thank you very much. You are the folks who have helped us to become one of the fastest growing database offering within Microsoft. So thank you very much. Now, I'm assuming that you have come here because you have issues, right? So without further ado, let's get in, right? First thing, there is always a greener pasture, okay? You should definitely, whenever you get time, join Cosmos DB. We are looking for people across the world. We today, I think it is showing there, but let me see if I can. You should try it out once you get time out of that. Let me see if I can just do that, right? And just project this guy for a minute, and then it should be OK, right? We are definitely looking for people across the world, across software engineers, PMs, pretty much everything. And please do try. There is tremendous opportunity. This is pretty much a once-in-a-lifetime opportunity at this point of time. So waiting for all the cosmonauts to join us. With that, let me get to my presentation, right? Which is, if I just do back. With that out of the question, I'll not, because most of you are already using Cosmos DB, all the stuff that you already know, that we are built for global distribution, we take care of a lot of things for you, we provide automatic or basically no thinking, elastic throughput as well as storage. We ensure that we provide all this by leveraging the Azure infrastructure, right? And the most important thing here is the resource governance model that we have built in across all these resources so that you can get the throughput guarantees, the latency guarantees, the availability guarantees. With that said, let us tackle the most important thing, right? This is, I hopefully I have not leaked anybody's name or something like that, but this is the kind of discussion I usually have. Most probably you'll not be able to read, but let me tell you, it's basically Govind. Looks like Cosmos DB does everything, right? You seem to be doing availability, you seem to be doing the low latency piece, and you seem to be doing throughput, you seem to be doing capacity and for this whole storage, as well as for throughput. So what do we do? Yes, there are a few things to be done, right? So we will run through a lot of things, and please feel free to interrupt me at some point of time. Do use the mics so that we can answer the questions. I have a lot of material to cover. As you, I think, possibly saw, I was trying to get ready, just ready up for the session. There is a lot of stuff. I may not be able to cover everything, but I have tried to create enough information in the slide deck which you can follow up later on to. Okay? If there are questions, feel free to reach out to one email alias that you should remember, askcosmosdb@microsoft.com for anything related to Cosmos DB. If you want to reach out to my address, that will be govindk@microsoft.com. So with that said, what is it that a developer or a DBA has to monitor or to manage the Cosmos DB itself? There are very few things. As we provide the backup, and I'll get into the details of the backup, we are going to improve it a lot. Let me put it that way, right? We provide the availability. That is the most important piece, because the way we distribute the data, we leverage our replication engine, and we can provide you local region availability for 4 nines, as well as 5 nines for the reads across multiple regions. And with the multi-master announcements, you should see an update on our SLA for the writes too. Security, also, we provide a lot of things out of the box. Yes, there are places for us to improve. So thank you very much for all the inputs that you keep providing. Expect a lot of things by the year end or a little later. So things that, what about this capacity? When you are working as a a database administrator, there are a few things that we always think of. One is capacity. We plan for it. Capacity is basically the storage. Capacity is also for the throughput in terms of the machine, kind, the CPU, amount of memory, and all those things, right? And then what the other place that we spend time on is the throughput. Throughput is ensuring X number of operations can be done without any challenges, right? So, and then finally, as part of the as sort of part of throughput itself, you also take care of latency. And what do we do in the latency? Across pretty much all of the databases, for the reads, we always use indexes, right? We provide latency guarantees for the operations, for point reads and point writes. We also provide good latency for the queries too, okay? And we will delve into what are the few things that you can tweak to get better latency or lesser usage of the throughput itself. Now, let me try to make a joke here. I call Cosmos DB, after having worked in the software industry for 20+ years, as the revenge of the database folks on the developers. This is the database where you literally can say, if you asked for X number of operations of certain kind, you are going to get that. That's it. If you try anything else, you are definitely going to get an error message, right? So that is a guarantee from the Cosmos DB. So that means that onus is now more on developers and database folks together to work, say that what is our real requirement, okay? So that's the key part that I would hope that you take away from this. So first part, capacity. So I'm jumping directly inside. So what are the few issues that I see daily, and I'm sure you folks see? One is the skew of the data. Why would the skew be there? Because you have not chosen a good partition key, or you expect the skew to be there because that's how your data load is going to happen. How do you notice it? You use the matrix, okay? So let me see. Generally, the right side thing is very difficult to achieve unless it is a pure key value workload. You would see if something on the left side, that kind of distribution, there is a problem. There is one particular partition key which is dominating, right? So where would you notice this? So let me just. Okay. The place that you need to come is the matrix. Okay. Did it? Sorry. 1 minute. Is it 7? Okay, it looks like, so apologies. I have removed the connector. Okay. Okay, so everything should be there now. You plan, and then you know the demos, right? Printers, projectors, and coffee machines, if you've not tried the ones in some sophisticated places. I think they are born to humiliate me, that's all. Okay, so what would happen is, I don't know how many folks can see at the back, but the key here is to go to the storage tab, okay? And notice few things. One is that we already provide you a data plus indexed consumed by the top partition keys. If something like this is there, then there is definitely issue. You should not have something like this, unless you expect this kind of distribution of data, okay? When does this happen? This can happen. Let's take an example. Suppose you want to store all the elector data of a country inside Cosmos DB. What should be the partition key? Let's take an example. Let's choose, if we choose a gender, what will be the issue? Maximum 3 genders, right? And only 3 partition keys will basically get filled up, right? Now that's not a great partition key. So what should be the partition key? Go back to the application developer or the business owners and ask, how are you going to query this data? How are you going to update this data? Generally, it will be precinct based. Pretty much all across the world, there is a concept of a precinct. And then you can see, oh, I think I should store data by the precinct, right? Similarly, you will have other kind of options too as you go along, right? There is one important fact here. The amount of data that you see is, right now I've stored humongous amount of data here, 1.5 GB. But the idea was just to show a few things here. The key part here is that the data size within a partition key range or partition key is equivalent to amount of data plus the index. And the index overhead would be around 20%. It varies a little bit depending on the structure that you have. Okay? But generally 20%, 15 to 20% is what you should see, right? And then what we do also provide is, okay, if that is the key, we also provide one more important piece of information there, which is data plus index by per partition key range. Remember, that was partition key, and I'll come to the partition key range. I'll explain that a little bit later on. Partition keys reside on the partition key ranges, and so on and so forth. So here you can see a particular partition key range has got more data. And looks like one of the partition key has a lot more information compared to everybody else. And somewhere here, this information would not even show up, actually, right? So this is the place that you should spend time on first to find out if there is an issue with your partition key. Now, there is a small thing here. You cannot automatically go and just change the partition key. You have to redo the whole partition key if this is something that you're seeing. Okay? How can you make your life easier? You can create another collection. You can use Azure Function or the bulk executor tool that we announced very recently to move the data. So that will be easier way to do it. Okay? With that, then there are a few things that I wanted to show you, if I can get that. One is that you can get a little bit more information from Cosmos DB. There are a lot of options within SDK. I'm sure many of you who have come like me from ADO.NET or JDBC or ODDB or ODBC, it's a very different model of programming, right? So there is request option and there is feed option and so on and so forth. The key part here to understand is there are few things which will be enumerated, query results, and few things that you work against. Okay? Anything which can be worked against will have generally the request option. Anything which will basically return an enumeration will have the feed options applied to you. So that's the simple way to understand. Here we are basically trying to get information about, give me your information about you. Here there are a few things. We will get partition key ranges. Now, what are partition key ranges and everything, we will get a little bit. You can get all the partition key ranges information. You don't have to take any dependency on them. You should not take any dependency on them. Idea here is if in case you want to understand how this whole thing is working, you can get that information. You want to get a few more things. One is once the information is provided by the information, you should be able to populate this out. So let us see if I can run this somewhere. There is one more, right? I need. So let me get. Okay. So what will this do? This is nothing interesting. You can try it later on. All these samples are nothing but I have just cheated. I have taken all these examples from our GitHub. Okay? So there is nothing very dramatically different from what we have. The idea here is you should know these things. So there is one small tip though. You see document count. Many folks come to us and say, can I immediately get a number of documents within a collection or a container? Yes, there is a way. you can get document count. This is not by any filter, you cannot filter it by any attribute. Just the raw document count or entity count is what is available. You will also get partition key ranges because you can get that information through the API. And then there is collection metadata. Why this would be interesting for someone? You are developing some tool which is basically doing deployment of stored procedures and all those things. You can utilize this. Okay. I think there are other things some folks do, but I think at this point of time, this is good enough to get. This is the maximum that of the Cosmos DB storage part of the world. Okay. What else can you do? Let's go back to there is one more I want to show you for partition stats, just in case if you folks are interested. You can search for our Cosmos DB GitHub samples from either of the search engines. Go for the .NET, and pretty much everything that we have is stored here. There is nothing hidden or something like that. Okay, so you can get all the information about how is each partition key range populated and so on and so forth. Okay, so with that, what I will do is I will switch back and come to something more interesting as we go along. And please stop me if you think this is boring or something, and just nod your heads even though you might be sleeping, just in case if it is interesting. So what is this whole partitioning thing? Partitioning allows us to scale out, so we need to get the partitioning right. Okay, so what happens? When you allocate a throughput, we automatically create the partition key ranges underneath to provide you the throughput. This is the key concept. And as your data grows, these partition key ranges will keep on growing. That is what is the elasticity all about. Okay, so when your data comes in with a particular partition key, we find out which partition key range it can go and sit in, and we just push in there. Okay, as more and more data for that particular partition key comes in, all of them go and sit in particular partition key range. If the partition key changes, chances are it may sit on the same partition key range or anything else. Okay, you don't control, we don't control. We just basically hash it and push it down. Now your question would be, what happens if once the partition key range itself reaches this limit? Interesting thing, we automatically split that particular partition key range. We move the data around for each partition key, whichever partition key has to be moved, all without you ever knowing. Okay, the availability, performance, everything goes on. All your operations keep on happening. Okay. Now, so the key part here to remember is, there is nothing that you need to do for storage management as long as you get the partition key right. This is very, very dramatic, right? Of course, now customers are coming in and telling us, hey, we should actually have ability to fence amount of data that we store. We don't want to store infinite amount. Right? So we are building those kind of capabilities as we go along. But practically, we don't have any limits. As long as we have the Azure behind us, we can store as much data as you want. So that's why when we say we can scale out infinitely, that's the key part. Okay? There's one more thing that I want to leave you with for the partition key piece. We have seen many customers use the 10 GB collection or the container without a partition key. Please don't do that in case you want to increase the size later on. You want it to grow, right? So what is the way out? Create a collection, create a partition, push all the data inside. Okay? And there are a few things, right? You want to do bulk delete. We have the now bulk executor. Use that to delete all the data. In case your application allows usage of TTL, you can use TTL too. Only thing is, TTL does not cost you any RUs, of course. So I would prefer that you use the bulk executor, but you can use some of the customers leverage that piece too. Okay. Sometimes what happens is the way you have stored the data and where you're querying it by particular partition key and and by its ID or other attributes is not enough for you. You want to query that data in a little different way and store it a little different way. That's completely possible. What you can do, create another collection, have Azure function which gets triggered whenever the data gets inserted. It pushes the data into another collection with a different partition key. Completely possible. Okay. What about if you have large documents? So this is something that we keep getting from customers from time to time. If we have a limit today of 2 megabytes, and that's for a good reason. If you have anything more, you should definitely store it out. First of all, store it in a blob. Don't store all of it. Most probably people don't need all of that data, because if it is 2 megabyte document or entity, lot of attributes will not be queried, so do not index them. So those are the few things that you can do. There are customers who basically store blobs and they stitch them together. That's also completely possible, but I would not advise unless you really require global distribution at our scale, right? Because, so that's the key part. Okay. What is when you have a large document, what is the impact for you? It is an RU impact when you read it. It is an RU impact when you write it, right? So you don't want to do that unless really required. What about if you have partition key sizes which are more than 10 GB? Now this is very much possible. We work with Azure AD. We work with applications similar to Azure AD, and Azure AD stores humongous amount of data within Cosmos DB for profile as well as the login events. Anytime across the world anybody logs in, all 10 million plus tenants of Azure AD, that data gets stored within Cosmos DB. Okay? That's the kind of scale that we provide at this point of time. And there are similar companies who have similar kind of workloads who push data at that scale. Now, key part here is, what has that got to do with this discussion? If you think of tenants of Azure AD, there will be a company like or a tenant like me, just with 2 identities or 3 identities at the most at home, versus a company would be a GE or Accenture, who would have 100,000 plus people, right? So partition key of 10 GB is not going to suffice. So what do? You add a known salt to it, and that's how they scale out. Okay? So you can store more than 10 GB of data per partition key as long as you know that you can add a salt to it. Okay? And this is very successful. Majority of the customers who have these kind of issues, they always leverage it. There is what one would say a tip for some very large customers in terms of, let us say you think that one tenant really cannot coexist with other folks. It's okay to create another collection for them, right? You don't want to restrict them with everybody else. Okay? Why would you do that? Because suppose they are very heavy in terms of throughput. That's also good reason for them to move out. Okay? Now, let's come to the performance part. So keep me honest on the timing. So this is you can clearly see I'm not an artist, and I've definitely not taken advantage of the amazing folks who are present in Microsoft to help me do this better way. But the key part of Cosmos DB is all the green looking folks are think of document client instances which are making requests, and Cosmos DB sits in the between. And whenever you make a request to Cosmos DB, any kind of CRUD request, and this is where the revenge of the database people comes in, right? We always tell you how much of throughput you have used for your operation, which is request charge, right? We always, if it is a query operation, we also give you how was this query executed, where did it spend time, which partition, how was it, whether did it utilize the indexes or no, or not, and so on and so forth. What is the alert part of here? You can create alerts to monitor this. You can use Azure Monitor in the future. We have started exposing few things into Azure Monitor. But ideally, you should store all this data into Azure App Insight, because you get this. When you invoke a command, you always get this information, unless you choose not to. Okay? What is this log analytics? How many people have used OMS or something? So everybody loves it, yes. app insights too. So what we do is we also provide ability to push all this data in an immutable format to log analytics or erstwhile OMS, Event Hub, or a blob. Why would we do that? Because in log analytics, as I will try to show later, you can actually make interesting queries to find out issues with your system. Okay? So this, if you understand this itself, I think how many people are actually storing request charge back? Okay, I think people are getting tired of me talking, I guess. Okay, how many people are storing query metrics or explode query metrics? Anyone? Okay, I will walk you through. It is extremely simple. Hopefully, after this, you will try it out. Okay, so what are the throughput issues, right? Throughput, as you understood, if you remember, you allocate throughput at a collection level, and the throughput gets equally distributed across all the partition key ranges. So what can happen? What can happen is basically set of partition keys can become hot, resulting in a particular partition key range, or set of partition key ranges becoming hot. So that indicates a developer like me is not very honest with you folks, right? So that means he needs to basically understand what is that really, what was the plan, and why did we end up like this? Okay. So why it can happen? There are three major reasons. One is you have provisioned very low throughput, and you are executing an operation which is taking all the RUs up. Remember, the RU is at a per second level, right? Otherwise, a particular partition key range or partition key itself is getting bombarded. And this happens many times when people do load testing. What happens is there is not enough variation in load testing. And invariably, only few keys get hit, either for the query or for the insert workload. And because of that, the partition key range becomes hot, and you start getting rate limitation. Other thing is, which is very valid, just the volume of operations, it just increases, right? That's a pretty valid way of happening. So how can you find it out? One is, of course, you will, if you set up alerts, hopefully you do set up alerts, you will find that out immediately. Second is you can try to get into all the alerts in a programmatic way if you want to do that. There is a way to do that too. Third is log analytics. I will tell you what is the issue with log analytics a little later. And push all the data into App Insight. So this is the way to do that. So now let's get to this side of the things. 1, 2, 3. Whoa. Whoever shoots these photographs. Okay, let's get rid of this, and let's come here. So your friend is pretty much almost always this particular tab here, right? So what would happen here is you would see the throughput across all the databases, across all the collections, and across all the regions. Normally, what I try to do is get a big picture view by clicking on 7 days. So here you can find out, okay, pretty much this was created most probably on May 6th or 7th, right? And then there are, looks like about 2K odd requests came in, and most of them were successful. You can click these things, by the way, right? And how many people are here MongoDB API users? No? None? Actually, we do a little better job in MongoDB API. We not only tell you which are the successful, not successful, and other requests, but we also tell you what kind of operation it is, whether it's a read, query, or anything else. Hopefully, very soon we will start exposing that here too. Okay, and so there are 3 things that you should try to. Okay, let me see if I. Okay, there are 3 places that you want to look at. One is let me pick up. This is one thing which has changed recently, and that's why it is buffing a little bit. So you want to choose the database and the collection, and then you want to focus your attention on few things. There's one important piece of, let me really tackle my laser pointing skills. There is collection has 5 partition key ranges, and the throughput is equally distributed, which is 400 RUs per second, right? And what you want to focus on is first is, was there any rate limitation happening? Okay. After that, you want to look at what did I provision? Okay, where is that? Do you see? Okay, there it is. Sorry about that. What did I provision and what was I trying to use? Okay, and then of course when you get a little bit more information on a particular day and particular time, was there any skew of my throughput, which is basically again 1, 2, 3. I think I'm not very good at this. I remember doing this in theater, but now I've forgotten the skill set. Okay, so that's the case. So what I do is, this is what I do, is basically there is a also you should use that too. So we have 7 days of data here, and you can store more data in log analytics or any place that you want to and do a lot more interesting things. But by default, we provide about 7 days of data. Okay, so what you could do is look at 24 hours. If you don't get, the idea here is to find out any kind of trend, right? Looks like it is up and down in this case. You can get more details. You can get more details by clicking on an hourly basis and going in here. Now this is pretty much at, if you see 216, 217, it's a per minute roll up data. If you come from the 7 days or the days or the 24 hours, this will be rolled up a little bit. So I would always just come to this granularity to find out the issue. Why we are doing this? We are trying to find out, what does this say? Max consumed RU per second for a given partition key range. Remember, we are trying to find out what is the whole idea about Cosmos DB. Cosmos DB, when you create collection, partition key ranges get created, on top of which the partition keys get set up. And when you are getting rate limited, it is the partition key range which is getting hot at a given point of time. So what we are trying to find out is how much throughput a particular partition key range is using. Okay. In this case, you can clearly see there is an issue. We have provisioned very less, 400 RUs, and we are trying to use almost 4K. So what is this time? So let's try to see what is the time here, which is about 214 or something like that, 213. Let's see if it is almost that. Yeah, looks like 213. Why would we do that? We would take that and enter that into just about that. There is nothing, 215. Sorry, did I need to do something? Okay. Apologies, I might have screwed up here a little bit. Yeah. Thank you. This is the dedication to craft. He noticed me going in and out, and he just came in. So thank you very much, Frank. So what you want to do here is 215 or 211, and let's see if we can apply it. So what we really are trying to see if we can get almost the exact amount. This is the place where we are trying to make more improvements. Sorry? Date is wrong? Date? Should it be 8? I definitely know that yesterday at this, just about this point of time, I did do some insert, and I think that will definitely show 105. Okay, so that means there is definitely something wrong. 58. So let's do that. It is right. Okay, 101. Okay, let me try one more time. So this is about 2:16 or 2:17 p.m. and it is 9. Sorry? Okay. So, okay. So let me try this 2:10. Let me try this at 8 a.m. That is not 8. That is about 8, yeah. It's so ideally what will happen. Sorry?
Look at the date and the hours. You're picking the wrong day. That's not today. That's yesterday's.
That is yesterday's, right? So let me pick up the that is just about 9, right? May 8th, 2, 3, yeah. So let me just put this 8 and 8 a.m. just about. Let's see. It is just about there. Let me just try to get the exact timing. Okay, so this should be about 8:17. So this is some of these things that 8:17, let's see. $8:17. It will be just around that time that we will get. Yeah, so what I was planning to show is basically is this, right? You would see that there are some partition key ranges which are getting hit at that point of time. That's what would happen. And idea here is if you see again a skew, 1, 2, 3 kind of a thing, then there is an issue there, and we need to see why that is happening. And that's the key part of this particular issue, right? Generally, this I think 8. I'll try one last time. I'll try one last time, PM. This actually, you see something has happened here, right? My clock has got completely skewed, and that is so 1 p.m. UTC. So that should be around oops, okay. I will give up on that part right now to get the exact timing. But what you will see is just like the storage throughput, storage skew, you will see a skew. In this case, I'll try to show you why it would happen. In this case, there are 2 or 3 places, right? One is, let's go here. I have got a bulk import running here, and you will see I'm just trying to simulate this, and this is what I did earlier. And this is something which is available. We are just trying to push data for one particular partition key. That's all. In this case, you'll continuously see this throttle happening, and you can go back and verify it on the screen itself. After some time, it takes about a minute or so for that data to appear back on the matrix itself, right? So this is very much possible when you're trying to do bulk loading or you are trying to do any ETL processes. Okay. So this is one of the reasons when you're trying to do bulk operations and you're not provisioned enough for the skew that you've created. Now what can you do? When you do bulk load, shuffle the data and push in. So a lot of people use Spark with Cosmos DB and shuffle the data and then push it in. Okay. A lot of people use our bulk executor tool too, because it has been there for quite some time. We just released day before yesterday, and shuffle the data and then push it in. So that way you're not pushing that particular partition, right? There is something else. In the real life, what might happen is you might have a particular hot partition key. So what do? In that case, you need to see if it is just a abruption or something seasonal. So how do you fix that part? If you think that that is just abruption for some time, that is perfectly OK. You can increase the throughput for some time and come back. But if it is seasonal, right, what you should do is you should take that hot data out, put in separate collection, and let it have its own throughput. Otherwise, you will be increasing throughput too much, right? Now, there will be a lot of questions about ability to scale up and scale down. I'll come in a bit as we go along. Okay? So that's first part of it. Then there is the key part here to remember is in Cosmos DB, the reads for 1 KB of data will take 1 RU, okay, regardless of anything else. Writes for fully automatically indexed quorum committed data takes about 5 to 6 RUs, always. Okay? So what I'm trying to show you here is basically it's a pretty large document which has been pushed in, and I'll show you a little bit of code later on. But there is a possibility, something like this, right? I'm pushing about 1 MB or something, 2 MB nearly of data inside. You will end up using a lot of RU. Right? So you should notice these things. Okay? Of course, you can do a few more things. So let's look at just that piece of code here. So what you would do is, the reading is pretty straightforward, right? And key part here is whenever you do read a document by the IDE, or anything, any operation, we always return a response information, right? You should always get the request charge and store it, because that gives you baseline for one read or one write or anything like that. This is the same case if you do a write too, right? So let's see. Which is the same thing here too. You would always do a write and then get the request charge of that, always. Okay? So this goes back to the original discussion. If you know your system well, there is no more art. It is pretty much nearly the science that we are trying to do here. Okay? So it has to be now, it requires a little bit more rigor on your part to push people to provide exact throughput requirements. There is no willy-nilly here anymore, where in older days, what we used to do with any kind of system, what kind of system should we have? Oh, there is a benchmark. But that benchmark is not my application. Okay? Then what do? OK, let me over-provision X amount. And that X amount is based on the experience that we all have. If you are a NoSQL developer or a DBA of a NoSQL system, what you would do is you would basically find out and allocate extra amount for a lot of operations. Here you don't have to do anything. You tell us the number of operations and provision that. Okay? Looks like I will need to rush through things. Hopefully that part is clear, right? So there is storage, there is throughput. If you get these two pieces right, pretty much everything is straightforward. Okay? So what do we have on this side? So the next is the query. So query also returns the query request charge. How do you find out? You always pass in the feed option, because this is an enumeration of the data, the populate query matrix. Okay? And we have existing documentation for this. Search for Cosmos DB query execution statistics. You will hit upon the first link in either of the search engine. Okay? In query, what you need to remember is amount of data that you read because of a query, and amount of data that you actually output. That is the key part. Now, with that, let's look at the query demos today. And please tell me if you've already seen this. I want to make sure that I can utilize your time well. So let's go and throughput. Let me close this. Let me close this. And let me close this. And OK, it looks like I still need. Oops. So a few things. What I'm going to show you is it is executing a query. And if we have time, that is, and if you folks are interested, I can walk you through all the queries that we have. It will take few minutes, not few minutes. It will take some time. And what I want you to notice here is basically the time elapsed. And what is this all stuff, right? What did go and execute here? So first thing is, we give you query matrix by partition, how much time is spent on each partition, how many times we tried to queue the job to the partition and get the data. That is basically given by this scheduling matrix. And when did we start? When did we end? How many documents did we come back? Looks like one document. Why did we retry? Because retry can happen, because you might have throttles, right? What do you need to focus on is the request charge. What do you need to focus on is the retry count. What do you need to focus on is index lookup time and index utilization. This is not completely correct today, but it provides a good index utilization is going to improve in the future. But the key part is number of documents I outputted versus number of documents I retrieved. That is the key part, because if there is a big difference there, you will see your RUs will get hit. Okay. Now, you might say, hey, this looks all text. Yes, there is a way to basically read this up and store it too. You should do that too. Okay. Now, why there are so many of them? Because we are executing bunch of these queries. How are we executing? We are basically getting two pieces of information. The query execution by itself is nothing much, right? We are just getting everything. What is the key part here? I'll come to this max item 1. This has got a big impact on what you are seeing right now, right? Is just giving this particular option, which is what is populating this matrix. There is no impact on providing this option. You should always do that, because we anyway generate this information for us. So there is no performance impact for generating this information. Okay. Once you get this information, it's pretty straightforward. I'm just dumping it. I'm not doing anything, because you can get various feed responses from each of the partitions, and I'm just adding it up and dumping it. All this information is on GitHub. If you don't get it, please send a mail. I'll forward this to you. It's straightforward. Okay. Now, so that's that part, right? So if we change this a bit, and I think I'm going to run out of time, so I'll skip this part. But if you want, you should try it later. The key part here is depending on the query, right? So you folks can help me out here. Which query here would be, I just ran the top 10. What do you think it was? It used a little bit of scan, a little bit of index, right? What about the starts with query? Or if a query contains lower or upper scan, right? We don't change there. So that means if you have an application which require contains, we do support contains, or is defined. Contains definitely is a search application. You should use Azure Search. We have a direct integration with them. If you provide us the ID and the partition key, or attributes and the partition key, we know exactly where to get in. And you will see the difference in the query execution matrix for all of these. Okay? If you give, the way it happens is, when you give the query can, the SDK can parallelize that execution across various partitions and get back the data in parallel. There is a way to control that, and that's what we will look at in a bit. Okay. So there is one optimization we don't do today, and that is something that you should definitely do, is basically use our subqueries, right? Well, idea here is that you are pushing the D-type equivalence condition into the from clause itself. Okay? And this you will see dramatic increase in your RU usage because we are able to filter out a lot of things. So this is something that you should definitely do. Okay? What else? So the usual thing that we find is you find that what is the performance issue? Either an operation or a query is taking long time. Your query is taking more RU. Why is it taking more RU? Is it using the index or not? You can find using the query execution matrix. Or if it is a stored procedure, again, using more RU, or just getting heavy latency, right? And we'll tackle the latency in a bit. So what can you do? You should basically log this information. I have not talked about how would you find this operation, right? I think you guys, you are two kind people. So there is one thing that I did not show you, and I think I have to show you this stuff, right? How would you know what operation you were running, right? And I don't know whether that is completely visible, but if you enable diagnostics, there are a few things which will happen. One is, if you have an alert, you will get an alert here. How do you do that? You come to the matrix, or basically the monitoring piece, and we have alerts here. You can set up the alerts. Okay, it will tell you when we just had a bulk uploader running, so it just got hit a few minutes ago. You can pretty much create alert on everything. Number of operations you should definitely do. Number of throttle operations you should definitely do. Number of errors you should definitely do. Right? So all these are here actually. You should definitely do throttle request, total request, max RUs per second, and average request per second, because you want to find out any changes. Okay? Definitely. Then what should you do after this? If this is done, you should enable the diagnostics logs. This diagnostic logs, if you enable, we push out the data to Event Hub, depending on your choice, blob or log analytics. In this case, I have done log analytics, and you can do the same. So you can push to storage account, Event Hub, or log analytics, and you can push all the requests as well as the data plane requests. So I will talk about this in a bit now. So what you see is once you enable the diagnostic log, you will start seeing all the push of data. This data in 15 minutes to 2 hours today. That's why I keep saying that use App Insights, and you can do pretty much similar kind of queries there. So if there is a requirement from your customer, from your side, to find out what was happening, you can always do something like Azure Activity and find out if Govind was changing a key, Govind added a region, Govind created a collection or not, created a database account, all those things basically from here. In this case, I have not switched it on. That's why you don't see that. But you can get that information. This is immutable log. Okay? The important event holder here for us is the Azure Diagnostics. What does it have? It has all the interesting information, and if I can get that is, you get information like, oh, that was an offer change. It happened at that point of time, and it took so much time, so on and so forth. Right? This is not so interesting. What will be interesting for you and me is basically start looking at how many different operations are happening at the backend. And it will show up. Okay? All this is documented, by the way. There are reads, there are creates, there are deletes, queries, pretty much everything. Okay? Now, hopefully, you're getting interested. What you would like to do is a little bit more than that. You would like to find out who is running more than 3 millisecond operations. There are a whole bunch of these people. You notice that last octet is 0. We basically obfuscated today, okay, for the privacy reasons. But what you would really want to know is, let us say, this is an interesting query, but today I will not run it because it will take time for me to render. But you can do far more better graphs than this. And you should definitely do that. And all these queries, if you ever need them, they are mostly on our website. But if you don't get them, send me a mail. I'll forward these. But what you would like to do is, are there any operations which took more than X amount of RUs, or which took more than X amount of seconds, right? So then you will start seeing interesting pieces of information. So you can see almost 200 pages, 50 items per page. There is read and so on and so forth. But what if you want to query these, right? So you can do that too. You would say that I only want queries. Please give me those. And you can get all the queries. What would you get? You can do pretty much everything here. You can get amount of time it took, where did it come from, what was the length of the response itself, and whole set of things. Now, your question would be, Govind, what about the query text? Today, we don't log it. That's why I keep saying use the app insights to log all the information. But in future, we are planning to see how best to comply and give that information. Okay, you should be at least the template text is our goal, but let's see. Not yet done. But this is the key places where you will find out. You go to the matrix, find out the issue, and oh, there was throttle. What was happening? Come here, find out the operation. If it is query, find out the query matrix, which query is creating an issue. If it is write, which write is creating an issue. There should not be any escape from this. Okay. With that, I will switch back to the presentation. Hopefully, it's still interesting. Yes? No? You're learning something, or you have to stop me because then I can do something more interesting. What is max item count, right? Max item count has so server side there are a few things you can control. While writing, you can control amount of RUs by switching off the index, and we will cover that a bit. By doing the right kind of query, you can make sure that you are projecting only the things that you require. You can ensure that you are using less amount of RUs. But what about the client side? Right? So what you can do is you can, when you see latency on the client side, there are usually two reasons. Either the operation itself is taking too long, or there is an automatic retry based on the because of the rate limitation. By default, we try 9 times. So an operation, if it gets throttled, we retry. If you don't override it, we retry 9 times. So you will see a latency. But what you will also see is if the max item count gets changed, you will see a dramatic. If you just set it to 1, you are only getting 1 item every time for a query result. That's not good. You should basically set it to high number. You should also set the degree of parallelism for us to decide. The SDK there are default numbers for these, and you should let us do that. Don't try to optimize based on the partition keys and everything, partition key ranges, because our SDK has enough intelligence to find out what the lay of land of the server side and get that information and do the right thing. So use the default where you let the SDK decide how to parallelize and how to get back the data. What is the max buffered item count? That's basically a memory on the client side is utilized to store prefetched items. Max item count, as I mentioned, if you just set it to 1 versus a bigger number, we will make more number of round trips to get your data, and you will see latency. Okay. The rate limitation itself, you can override it. Whenever the rate limitation happens, by default, as I mentioned, we have a set of defaults, but you can retry it if you don't like that behavior. Why would you do that? Because you don't like the latency impact. Okay. Now this is something I think I repeat, but end of the day, you can create the collection or the containers, and the data and the throughput gets equally distributed. Key part is, remember, and if I can make that statement here, right? Every operation takes an RU, but known amount of RU. Every read and write, point read and write never changes, regardless of petabytes of data. Query can change because your query can have amount of data which is getting possible candidate can increase or decrease, right? But anything else doesn't change. TTL operation does not use RU, but you can, if you want to do the bulk delete, use the bulk executor. Okay? You should always log that information. Just for a few things, right? If you have, how do you do the capacity planning? 1 RU for read for 1 KB of data, 5 to 6 RUs for write for completely indexed data. Let us say you provision about 100,000 RUs, and there is a particular query which takes 50 RU. How many queries can you run? you can run about 2,000 queries per second, right? And each partition key range can go up to 10,000, right? So if you want more, right, you want million RUs, 2 million RUs, contact us. There is no limit. Just like we don't have limit for the storage, we don't have limit for the throughput too. Yes. But it's all about how much money you're making. So, but there are customers who are running millions of RUs per second at this point of time, and we are very thankful to them. We will keep optimizing this behavior as we go along. Now, the capacity planning is basically, calculator will give you CRUD operations, but for your queries, you should definitely add them up. Okay, and then add that information and say, this is my throughput per second. And this is the holy grail that we have been trying to basically nail down, saying that you should be able to tell, this is the throughput I need, and we will provision it, and we will stand by it, right? And as long as the people who have estimated the throughput, they are right, the system should just work fine. And majority of the customers who first start using it, they find advantage and just keep on using more and more. How do you track it? As I mentioned, how do you scale it up or down? Everybody knows this, right? Or no? Yes? No? No? So everybody knows it. Okay. So you can scale it through code, or you can scale it through the portal or SDK. It's very straightforward. It is instantaneous. There is no limit on number of times you can increase or decrease, unlike the other guys on this side. So this is not really required. There is one piece of information. We have also one tab there called as metadata requests. We used to have a way to query all the resources. If you have attended Andrew Liu's session, we have a resource model underneath. And usually people would do query. Don't do query. Just use URI method to get to your resource and cache it. It will be fastest way. Okay. Otherwise, you'll get throttled on that too, because that information is also rate limited. Okay. So what can you do on the client side? You should try to use TCP direct. You should co-locate your client and make sure that look at the query execution statistics and the total execution time. Find out if server is spending time or is it the client which is spending time. You can get very easy information, right? You should scale out your data if you have a lot of stuff to push in or take out, and increase, at least in .NET, you can increase this right at the TCP level. Okay. There is a rare time that you might need to switch on client-side matrix. Do not switch it indefinitely, because this will fill up your disk. The usual thing that we have found out that is customers are trying to use very low number of CPUs machines. That's not a good idea. We use CPUs. Okay. If you have a heavy system and it needs to go across multiple partitions, it will use heavy number of CPUs. So ASC, if you're using ASC, go for dedicated if you have heavy workload. Okay. So that's one thing that I would suggest. And people who are leaving, please do give the feedback. I appreciate that. Thank you very much. I can improve next time. What about index? We auto-index all the data. Auto-index all the data. That's a big relief, right? Before working on any kind of application, whether it is NoSQL, across the lake, actually I'm on this lake side itself, yeah. Within this perimeter, you still need to do index management for that other hosted database. NoSQL databases or relational databases, you still need to do index management. But with Cosmos DB, you do not have to do anything. By default, you do not have to do anything till, of course, you start storing 2 megabytes of documents and you only query 4 of those attributes. Okay? That time you should switch off indexing. You want to avoid lazy indexing for simple reason. What I have found out in the last 2-3 years is basically I set it up, but the person who is doing the query does not know about lazy indexing, and he will get completely different results, because we index the data when there is no operation on your behalf. So not a great idea to do lazy indexing if your query operations are very heavy too. Okay, how can you disable the index? Very straightforward. There is a sample on our GitHub as well as other places. We can be a complete KV store. Just mark ID as the partition key, and trillions of keys are completely okay. Okay, you switch off the index and just mark ID as a partition key. We become a key value store. Okay. I will not spend much time. I hope you have understood this in enough of our discussions. But the key part is we treat index as inverted index. We get all the data. We treat all your documents in a form of a forest. and create an inverted index. What you need to remember is, do not fiddle around with precision if you don't know what you're doing. Just let it do the maximum, whatever precision which is there by default. It will do the right thing. Majority of the use case, use range index. There is no reason for using hash index unless you're doing scalar, pretty scalar equality queries, because this can cover both equality as well as range queries. This is a longer topic, but if you do think that you have a set of hot partition keys and you know them, move them out, or read them from another region, or pre-calculate them. Don't try to basically do a runtime calculation of all those things. Okay? So what is a good, if you look at performance, what are the things? Get will be the fastest, query with a filter clause will be little slower, or little less, more RUs, and so on and so forth. What is better? The bulk insert with our bulk inserter tool is always the better, or you use the put from this side. TTL delete is of course better, but if you want to do a delete using the bulk executor, best, because it's the fastest. If your application model allows, you can save RUs again. Use eventual. Eventual in our world, actually I didn't get time today to get into, but eventual in our world doesn't mean that data will take minutes, hours, or something. Data gets instantaneously pushed across the world. It is only limited by the speed of light. So that means as long as your application allows to read eventual data, you will use, for given throughput, you will actually see double amount of workload that you can push through. Okay? Availability. So I have about 6 minutes. Let's see how fast I can do this one. Right? We provide 4 nines within a region. If you have attended Andrew's session, we provide replica sets. So that means your partition is backed by 3 more replicas. You never see them, you never manage them, you don't have to worry about them, which allows us to do a quorum write, completely indexed, and allows us to do updates continuously. Actually, we are updating as we speak, okay? And there is no impact on anybody. We give financial guarantees for all these. We provide 5 nines for reads. If you enable, of course, multiple regions. As you must have seen that we also provide multi-master, and we will update these SLAs as we go along. Enable auto failover. It's something that you opt into. And leverage the manual failover. There is no loss of data or availability when using manual failover. This is something very unique. Many of our customers use that. And if you are interested, we are also working for the last 6 months with various customers for multi-region strong. If you remember, we have 5 consistencies. But if you want 4 regions or 3 regions which are 100 millisecond apart to be consistent, strongly consistent before the write comes back, please let us know. Send us a mail, ask Cosmos DB. We are doing a preview at this point of time. Okay? This is something else that you can do. What is the thing that you need to remember? You do not have to worry about availability because both automatic as well as manual, the SDK is intelligent enough to find out which is the right region to failover to. Of course, you have to give us the right priority. Do not, if you are distributed across the globe and your right region was, let us say, US, and suddenly you switch over to Japan, not a great idea, right? 220 odd milliseconds, that will time take. But you can do this pretty much often, right? Manual failover, no data loss, no availability loss. Everything can keep continuing. Sometimes what you might see, I want a little better performance. You want to go ahead and use TCP. There are unique cases when people's reads are going to right region. And generally, it is because they have not set up the preferred location or not set up the enable endpoint discovery. And the reads, when they fail over, the reads are not failing over because they are not checked the enable read request fallback option. So these are the things that you definitely need to check. Backup restore. Okay? Today, we provide 2 free backups. These are snapshots taken at every 4 hours. And they are directed towards, hey, I deleted something by mistake. For HADR, always leverage our globally distributed mechanism. And as you can only say so much, a lot more is coming. Please stay tuned on this front. Errors. Always, always expect errors. Right? So document client exception, you should capture it. Rule of thumb, all the reads can be retried. Writes, you have to take care because you know your application better. So there are a few things. You should take out error code, status code, and response header and log it. Okay? When you get an error, what about, there is an activity ID. Every time you do an operation, we give an activity ID if you hit us. Okay? If you face an issue, always use activity ID to tell us, okay, this was the issue. Maybe more RU, more latency, whatever, right? Let us know. These all status codes are basically documented. You will see 429 if you're doing at that level, or SDK takes care of that. 500 is definitely an issue. You should definitely reach out to us. 503 is retriable, so do not worry about it. Okay? What else? Security. As I said, I will not be able to cover pretty much everything, but I'll try to rush through. We announced, we provide what I would say we are on a path to make this whole thing better. But where we are, we encrypt data in rest and data in motion. There is no opt-out feature for you. It is always that way. We provide IP firewall, and we announced the VNet service endpoint. We provide key-based authentication, which you can rotate and you should rotate. Expect more as we go along. I think I can see other questions on that, but hold on for a few minutes and I'll come to those pieces. We audited all the operations. You should use log analytics to push all that information so you can do your own auditing or something else at this point of time. What about if you want to do resource level blocking of the operations? You should use token broker now, but it will improve. This whole feature set is going to improve as we go along. There is a lot of compliance that we comply with. I have not taken time to note them down, but please go to Azure Compliance and you'll see our name pretty much everywhere. What if you're doing bulk load? Increase the RU and shuffle the data and push it parallelly. Do not use ODBC because it does not know a distributed database. It will not work out well. Okay? So use the native drivers that we have. They will work out okay. We already have the bulk executor. We will be integrating it with ADF v2. We already have integrated with the Spark, so you can utilize it directly. A lot of customers use Spark to do ETL with us. You want a copy of database. Hopefully, when we have the backup restore, we will be able to do a lot more of those things. But today, just change feed and Azure function, right? Now, let's see if I can really finish this, right? There are a lot of things that you'd never ever get to cover in the RSDK. Few of them I have tried to cover here. Connection policy is important. You tell us how you're connecting, direct or TCP. You can also go to gateway mode, then there is no TCP for that. And then you should definitely add the preferred locations. Okay? Why max connection limit? We discussed it earlier. Enable read request fallback, we discussed earlier. When you fail over, you want to make sure that reads also fail over. And endpoint discovery is important because when you create an account, it does not know about how many regions you are. So SDK will find out if you set this option, how many places you are located, and it will do automatic failover based on whatever you have set to us. That's why the priority in the account matters a lot. Okay? Feed options and request options. Anytime anything has to be enumerated, push control everything from there. Request options is basically you are trying to create an index, you are trying to create a collection, you are trying to change the offer. Everything comes through request options. Okay? Change feed options. There are more options. So you can do read from the beginning, read from this place, read from the token, all those kind of things, right? Stored procedure. Use stored procedure for write because we provide ACID compat via stored procedures. Either a stored procedure batch will finish or it will complete, or it will error out. Very important thing. Okay? Don't use it for just read purposes. There's no point in it. Okay? There is small thing there, patches, inserts, update, use our bulk executor. It will do all the things right way. So I think I'm just about in time, right? Hopefully you guys will forgive me for just rushing through a few things, but hope. So what do you need to do as a DBA or a person who is managing the Cosmos DB? We do pretty much a lot of things, but what you need to make sure is get the partition key right, get the throughput right, and then monitor the throughput and monitor the latency that you're getting. And storage we are anyway doing. Availability management, you should definitely have more than one region always, right? And ensure that you log information in log analytics or in your own app insights and analyze those and then move forward. So with that, I will just take questions if there are any at this point of time. So thank you very much for your patience. I might have rushed through here, but I hope it was useful. So everything should be here mostly. Remember, there is Ask Cosmos DB is our alias. We try to be as fast to respond on that. So reach out to us. Thank you very much again for your support as we develop this application as platform. There are a lot more exciting things through the end of the year. So if just the beginning. So thank you again.